The Texas coastline is a dynamic and sprawling expanse. It stretches for over 367 miles along the Gulf of Mexico. In early May 2025, this familiar landscape presented an alarming new feature. Reports began to surface of unusual and extensive cracks appearing along various stretches of the coast. Local fishermen, often the first to notice subtle changes, reported long, deep gashes in the earth near their usual fishing spots. Beachgoers, too, encountered these unsettling formations. The cracks varied in length and depth, some several feet wide and plunging deep into the ground. The initial reports painted a picture of a widespread phenomenon. The cracks were observed in multiple counties along the Texas Gulf Coast. This geographical spread suggested a potentially large-scale underlying cause. Scientists and state officials were quickly alerted to the situation. The Texas Commission on Environmental Quality and University Geology departments began to mobilize. Their first task was to document the extent of the cracking. The appearance of these deep cracks marked the beginning of an intense period of investigation. The mystery of the fractured shoreline had begun, and answers were desperately needed by the anxious public. News of the coastal cracks spread rapidly. Local news outlets were the first to report the strange occurrences. Soon, state and national media picked up the story. Images of the deep fissures dominated television screens and online platforms. Public reaction was a mixture of fear and disbelief. Residents living near the affected areas were understandably anxious. Social media buzzed with eyewitness accounts. The scientific community responded urgently. Geologists and engineers converged on the affected regions. Preliminary observations confirmed the severity of the situation. State and local authorities moved quickly to address public safety concerns. Areas with significant cracking were cordoned off. Warnings were issued to beachgoers and boaters. Officials aimed to provide residents with accurate information. The search for the truth behind the mysterious coastal cracks was officially underway. One of the initial lines of inquiry focused on natural geological processes. Could tectonic activity be responsible for the sudden appearance of these cracks? Geologists began examining recent seismic data. They looked for any unusual tremors or shifts that might coincide with the formation of the fissures. Another significant natural factor under consideration was the presence of growth faults. The Texas Gulf Coast is underlain by a thick wedge of sediments. Growth faults are common in such environments. Scientists hypothesized that recent movements along these pre-existing growth faults could be a primary cause. Field investigations involved using sophisticated equipment. Ground-penetrating radar was employed to map subsurface structures. GPS measurements were taken to detect any ongoing ground movement or subsidence. Preliminary findings from these investigations started to paint a complex picture. While a definitive link to specific tectonic events or growth fault movements was still being established, these natural geological features remained high on the list of potential contributors to the coastal instability. Beyond natural causes, investigators closely examined the potential role of human activities. The Texas coast has a long history of intensive industrial development. Oil and gas extraction is a dominant industry in the region. This extraction can lead to changes in subsurface pressure. Scientists began to correlate the locations of the cracks with historical and current oil and gas field operations. The practice of hydraulic fracturing, or fracking, also came under scrutiny. Fracking involves injecting fluids at high pressure into rock formations to release oil or gas. This process can induce small seismic events and alter subsurface stress fields. Groundwater withdrawal is another significant human activity impacting coastal geology. Extensive pumping of groundwater from aquifers can lead to a significant lowering of the water table. When water is removed from the spaces between sediment grains, the sediments can compact. This compaction results in land subsidence, where the ground surface gradually sinks. Scientists considered whether a combination of these human activities might be at play. The removal of oil, gas, and water all contribute to changes in the subsurface environment. The human footprint on the Texas coast was undeniably large. The appearance of deep cracks along the Texas coastline sent ripples of concern through the ecological community. Coastal ecosystems are incredibly sensitive and highly productive. Salt marshes, for example, are vital habitats. They act as nurseries for many commercially important fish and shellfish species. They also protect inland areas from storm surges and erosion. The new fissures threatened these delicate environments. Cracks could alter drainage patterns, leading to saltwater intrusion into freshwater marsh areas. This change in salinity can kill off existing vegetation and disrupt the entire marsh ecosystem. Estuaries, where freshwater rivers meet the saltwater of the Gulf, are also at risk. These brackish water zones are biodiversity hotspots. They support a vast array of marine life, including oysters, shrimp, and crabs. Changes in land elevation or stability caused by the cracking and potential subsidence could impact water flow and sediment deposition in estuaries. Coastal wildlife, particularly bird populations, faced new threats. The Texas coast is a critical stopover point on major migratory flyways. Habitat degradation resulting from the cracks could severely impact these bird populations. The long-term health of the Texas coast's unique natural heritage was clearly at stake. The mysterious cracks scarred the land and deeply affected Texas coastal communities. The economic impacts were immediate. Coastal tourism is a major revenue generator. Dangerous fissures led to beach closures. Local businesses reported a downturn in activity. The commercial fishing industry faced challenges. Coastal infrastructure damage was a pressing issue. Property values began to decline. The psychological impact on communities was profound. Historical precedents offer valuable insights into the current crisis on the Texas coast. The Houston-Galveston region has a well-documented history of land subsidence. Immediate safety measures were the first priority in response to the May 2025 cracks. Authorities quickly cordoned off the most hazardous areas to prevent public access. Geotechnical engineers were deployed to assess the stability of critical infrastructure. Long-term solutions require a multi-pronged approach, focusing on resilience and future prevention. Investment in coastal restoration projects can enhance the natural resilience of the coastline. The mysterious cracks of 2025 remind us of the complex interplay between natural forces and human actions.